Ladies and gentlemen, let me present my 10-year R&D journey to develop the knowledge needed to create advanced robotic systems within Sri Lanka. Over the past decade, we have developed robotic systems. We have built embedded controllers and motion control technologies and industrial automation solutions. This journey was not merely about building robots. It was about developing the knowledge and practical experience needed to create advanced robots. Today, I would like to share the lessons we learned, the challenges we faced, and the opportunities ahead as we enter the era of physical AI. Let me request my team to continue with this presentation.
It started with story, my professor heard. This stupa was built using huge amount of bricks, sufficient to build a wall approximately 156 kilometers, 22 feet high and 2 feet thick. Imagine its size and length. Yes, it is a huge wall built from Colombo to Matara along the coast. Can you identify this stupa? Bup, bup, bup. Yes, you are correct. This calculation was in the annual report sent by the assistant government agent to governor in 1870. It is still available in the Department of National Archives. You can go there and verify. It is estimated that at least 3 decades needed to build this. This massive construction is based on this small piece of brick. Amazing, isn't it? This is a very good case to understand our ancestors' capabilities, their indigenous knowledge. Can we do massive projects like this again by developing our indigenous knowledge again? While on sabbatical leave in 2005, he encountered the term artificial intelligence for the first time while searching for new project opportunities. The fear and uncertainty he felt in that moment was terrifying. Yes, terrifying. What would happen if factory workers were replaced by artificial humans? What would happen to countries like Sri Lanka, whose industries depended heavily on human labor? Would our factories survive? Would millions of jobs disappear? Would entire industries become obsolete? These questions stayed with him for years. The more he learned, the more he realized that this was not just about technology. It was about the future of nations. If intelligent machines could perform physical work, would low-cost labor still matter? Would factories continue to move to countries like Sri Lanka? Or would manufacturing return to the countries that owned the technology? And if Sri Lanka failed to develop its own automation capability, would we be left behind? These were no longer academic questions. They were questions about our future. The fear he felt in 2005 eventually evolved into a mission to help Sri Lankan industries move from a dependence on low-cost labor to a future built on technology, innovation, and engineering capability. To achieve this vision, he focused on 3 areas: developing affordable robotics platforms for SMEs, creating AI-enabled automation solutions for industry, developing the next generation of Sri Lankan engineers. This has been his mission for the past 10+ years. The summary of 10+ years of work. In 2015, he embarked on an ambitious project. The goal was to develop a 6 degrees of freedom industrial robot costing less than 1 million rupees, making robotics affordable for Sri Lankan SMEs. To achieve this target, the design relied on several innovative ideas: sensorless stepper motor control, locally manufactured gearboxes, low-cost robotic architecture suitable for SMEs. However, the project did not succeed. The technical challenges proved far greater than initially anticipated. But the failure revealed an important lesson. Building advanced robots requires much more than assembling mechanical, electronic, and software components. It requires the development of deep engineering knowledge and technological capability. This realization would shape the direction of the next decade of research and development. Here, you can see a result from the initial attempts. It is one of the stepper motor driver developed by the team. The motor drives could only rotate the motor at a low speed. The speed was not sufficient to drive a robot arm. Few years later, they were faced with the engineering reality. Robot could not be driven with sensorless stepper motors. Further, they realized that manufacturing a backlash-free gearbox was a very tough task. With those failures, the startup euphoria came to an end. Although startup euphoria came to an end, my professor did not give up his mission. He looked for alternatives. He realized that developing a gearbox may take years, hence decided to develop robot controllers and controller algorithms using prototype robots manufactured by imported motors and gearboxes. Although this decision made him to spend a lot of funds for R&D work, the team succeeded in developing a multiprocessor robot controller successfully. The research on low-cost gearbox continued. Instead of using stepper motors, they decided to develop servo motors and servo motor drives locally. These are some gearbox designs they tried out. Unfortunately, all these attempts did not give a reliable gearbox. Well, servo motor development was not hard as the gearbox development. Here you can see 3 different servo motor designs. All these designs are in working order and using in the robots developed by the team. Here you can see 2 prototypes. They were primarily used for robot controller development phase. These are 2 60OF robots. The yellow robot was developed using imported motors and gearboxes, while the orange one has imported gearboxes and locally developed servo motors. This slide shows 2 SCARA robots. The left unit is built using imported gearboxes and imported motors. The right unit contains imported gearboxes and locally developed servo motors. Here you can see some parts of a SCARA robot, including the parts for the motors used in it. This slide summarizes a decade of learning. The first low-cost robot prototype was built in 2015. While testing and doing alternative designs, they realized the engineering reality. After understanding the engineering reality, they continued to make better motors, better drives, better gearboxes, and better robots. Today, they are concentrating toward development of AI-enabled robots. As we look toward 2035, we believe Sri Lanka has the potential to become a nation that creates technology rather than merely consumes it. A nation that develops its own automation technologies, builds physical AI solutions for industry, and creates engineering products that can compete on the global stage. A nation that produces world-class engineers, researchers, and innovators who are capable of solving our own problems and contributing to the world. Our journey must be a transformation, from consumers of technology to creators of technology. We have spent more than a decade building the knowledge and capabilities required to develop advanced robotics and automation technologies within Sri Lanka. We welcome partnerships with industrial customers, technology collaborators, and investors who share this long-term vision. Together, we can build globally competitive engineering solutions and help transform Sri Lanka from a consumer of technology into a creator of technology. Thank you.